What is up, everybody? All right, so we are now to unit 4.3. So previously we talked about how triangles are congruent if all of the corresponding parts are congruent, right? So you have 3 different pairs of angles that are congruent. You have 3 different pairs of sides that are congruent. And so if they're the same shape and the same size based off of all those things, then the triangles are congruent. However, in order to determine if triangles are congruent, we don't have to know all of those things. There's 5 shortcuts that we're going to go over that allow us to determine if triangles are congruent without knowing every single piece of information about each triangle. Okay? And so we're going to do 2 today, and then we'll do the rest of them in other videos. So the first 2 that we're going to do are this guy and this guy right here. And so as we look at the first one, it says 3 pairs of corresponding congruent sides. And so we call this one side, 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 or we just call it SSS for short. And that means that all 3 sides of one triangle match up with all 3 sides of another. And this is the one that's usually the easiest to spot amongst the 5 different ones, because it's super easy. It jumps out at you. You notice you got 1 dash, 2 dash, 3 dash, 1 dash, 2 dash, 3 dash. You notice that each side has a corresponding congruent side in the other triangle. That is enough information. So that right there is enough information to determine that triangle on the left is congruent to the triangle on the right. Okay, so our first one is side, side, side. The second one is when you have 2 pairs of corresponding congruent sides and a corresponding included. So that word included is super important. A corresponding included congruent angle. So what included means is that that angle is between the 2 congruent sides. It's being made by those 2 congruent sides. And we call this one side angle side, or SAS. And so again, notice how our angle right here is between, it's being made by the single dash and the double dash sides. In between single dash and double dash sides. So that is SAS. The most common mistake you will ever see is if you have 2 triangles and one triangle is marked like this and one triangle is marked like this. You have a single dash triangle, you have a single dash side, you have a double dash side, but notice in that second triangle over here that the angle is not between the 2 sides. Okay, it's not here, it's off to the side. And so I'll talk about how we read triangles after we've covered them all, but actually, you know what, I'll cover that right now. So let's look at this triangle here. The way that you read a triangle is that you can never skip. And so what I mean by reading a triangle, guys, is you're looking at the markings in the triangle. And you can never skip consecutive angles and sides. So let's say I have these markings here. That reads SAS if I go left to right, or it reads SAS if I go right to left. You cannot go side this direction, side A. So you can't say SSA. All right? Because notice, if I went that direction, I'd be skipping this angle, I'd be skipping this side, and I'd also be skipping this angle. You can never skip an angle and a side consecutively. If I'm going to skip an angle, I have to talk about the next side. If I'm going to skip a side, I have to talk about the next angle. Okay? So this one would read ASA. ASA or ASA. That would not read AAS because as I go around this way here, I'm skipping a side, I'm skipping an angle, and I'm skipping another side. Okay. So as long as you remember you can never skip consecutive angles and sides, then naming the triangles should be fairly simple. So let's look at some of these ones right here. So we have lots of examples, lots of stuff to practice, and the only way to get good at these is to just practice and see how they look different, right? So if I look at number 1, okay, I don't have any angles marked. That should just jump straight out at you that you don't have any angles that are marked for you. So that one's going to be SSS. So all you have to do is write SSS, side, side, side. Okay. Number 2, I have 2 sides. I have a single dash. I have a double dash. Look at the location of the angle. So this arc, this single arc that there's in there, that's saying that that angle is congruent to this angle. Is that an included angle? Yes, it is. So that would be side, angle, side. Okay. Let's look at number 3. I have a single dash. I have a single dash. I have another single dash, but I don't have another one. So what that means is that this side is congruent to this side here. But on the one on the right, I have a double dash. So that cannot be SSS. So you would just say not congruent for that one. Number 4, single dash, double dash, right angle, right angle. Is that right angle in between the 2 sides that we know? Is it included? Is it being made by the 2 sides? The answer is yes, SAS. Number 5, single dash, double dash. Now this is what we call a reflexive side. It's a side that's being used in both triangles. And that side has a very specific set length, and it's never going to change, so that means it's congruent to itself. So that side is congruent in triangle 1 to the same side in triangle 2, so we say side, side, side. Next one, number 6. Okay, so as we look at number 6, single dash, double dash, angle, angle. Is that angle between the 2 sides we know? Yes, it is. SAS. It's pretty easy once you get the hang of it. For our last ones, 7 through 12, single, double, angle, angle. However, this one is between, this one is not, so not congruent. Okay? Number 8, single, double, triple, SSS. Single, double, between, yep, SAS. Side, side. Single, double. This one would read SSA. This one reads SAS. So we say not congruent. Single dash, double, triple, side, side. So those are our 2 first ways of determining if triangles are congruent by using minimal amounts of information. Homework is very short. Good luck.